Hello all. So in this video we are going to present our IBC project, that is the in the course of Introduction to Blockchain and Cryptocurrency. So I'm going to start with the presentation slides and I am going to explain in detail with all the slides. So so one second, let me share the screen. So this is our IBC project presentation, and the flow in which we are going to present our presentation are. So with the table of contents first, we will going to start with the introduction. Then we will be explaining the tech stack we have used. Then we are going to explain the smart contract code and how we have made it, with what thinking we have made it. Then we are going to explain the compilation and deployment. Then we are going to give the demo of the project, like what are the workings of the project and how it is working. And then we are going to explain the workflow and challenges. So our team comprises of me, that is Bhavik, and Hardik and Ritvik. So we three are comprised of this team. And let me start with the introduction. So first of all, the problem statement that we have uh, initially thought about was to solve the problem of event funding. So event funding is basically like whenever a major festival happens, so in a society, some people give the funds to a certain set of people, and that certain set of people who are on the top of the hierarchy buy the products from the market to organize that event. So sometimes like that happens that well, like we as commoners, when we give some money to the like the people at the top of the hierarchy or which are the leader of the committees to buy some products, so they can use some funds for their own personal use and some funds to buy the products for the festival or something, the event that is happening. So we try to use blockchain to avoid that problem, that we can see that if the people we are the leader of the committee are using the funds for only proper use and not for improper use. So like first of all, this was a traditional architecture that was followed. So now then we would be showing in the further slides that how does blockchain help, like how did we use the concept of blockchain to solve this event funding problem, in which the people use money for people don't use money for proper buying and proper funding, and they are corrupt. So then we solved this problem using blockchain. So as I explained in like brief first of all, but now I will explain in detail in this slide. So the thing is, like you can see at the bottom of the screen, so these are five society members. Okay, like there is a society in which there are five society members. So in general, time to time they pay funds to the particular fund to whenever the event will be organized, the money from that funds would be taken out by the fund manager, like which are the top of the committee, and they would use that money of the society members to buy some equipments for the event, as I explained. So what happens, the problem is that as I explained, like these managers or the members who are on top of the committee can use a portion of money to buy some cheap equipments, like not of proper quality, and use the remaining funds for their personal use. Like we won't even know that we have submitted funds in the society fund. We as a member have submitted funds, but we don't know like how they are using. Maybe they have used some funds for personal usage and some portion of money to buy materials for cheap equipments. They can show us wrong will that we have used it all, but maybe they have used for their personal use. So to solve this problem, we applied the concept of blockchain. So what we did in this project was, like when what happens is that the initial left structure is same, like these are the five society members and these are going to pay funds to the society fund, in which the committee members are going to, like the fund managers are going to use money to buy the equipments. So what happens is that, like they have used a certain money, okay, in like in the previous year, to buy some good equipments. Okay, the equipments that are of quality and are of proper use. Okay, but what happens now is that if they try to again use remaining funds for personal usage or some portion of money to buy materials, cheap equipments, so at every time a certain request is created by the fund managers or the committee members. So 50% of the members, like the normal society members, have to approve to forward that request. So what will happen is that when they would be giving the certain request that buy some good product, we are going to buy some goods of this price, certain price. So if more than 50% of society members think that they are using money for the right purpose, they are going to click on approve. And if more than 50% thinks that is right and approved, then this transaction shall be going forward, and they can go buy good equipments. Now think like if some funds are left, and like the fund manager, they decide to do buy some products for their own good and not for the whole society. So they would be giving out a transaction, the fund manager, that I am using this fund for this use. So then what will happen is that when society members will see that this is not for the event and they for their own personal use. So most of them are going to disapprove this request, and so the corrupted committee members could not move forward with this request for their personal usage. Same is the thing with the when they are going to buy cheap equipments. If the society members think that the equipment they are buying with a certain price is not of good quality and they should not buy it, so more than 50% of the audience would of the members wouldn't approve it, and so the transaction won't move forward. So we have used the concept of blockchain here, in which like more than 50% of common society members have to approve the request to carry out the transaction. If they more than 50% does not approve the request to carry out the transaction won't move forward, and the corrupted committee member won't be able to like corrupt in this, like won't be able to do bad things in the committee. So this problem corruption could be solved easily. Like this also could be translated to a like this also could be translated to a very big scale in politics also, if we think of that. In general, this problem is happening in majorly in many areas, and we could solve with the like we solved on a small scale, we can solve this problem using blockchain on a big scale also. So this was the like the event that is happening. The contributor creates a spending request. The contributor gives the money in the contract. The manager creates the spending request. So whenever the spending request is created, all the contributors would be given option to approve or disapprove. If more than 50% of them approve, the spending would be done from this contract. Otherwise, spending would be cancelled, this transaction. So spending request attempts to withdraw money from the contract and send to an external address if more than 50% of the contributors agree. Like they all would be given option to agree or disagree. So this was the basic thing, and this is the tech stack. This tech stack we have used is React JS, and these are all the things we have used. Like these are the normal software that we're going to use. And moving forward, the all of the things like would be going to explain by Ritvik.
Architecture of the project. Unlike traditional architecture, server has a minimal role to play in Ethereum apps because all the writing of data and all the transactions are recorded into the blockchain network using on the client side. So the client connects to the website using Web3, JS, and MetaMask. And MetaMask has all the public and private keys and accounts of the client. And whenever client demands to make a transaction or any change in the data, a gas fee has to be paid by the client. So the server or the host of the website doesn't make any change in the data because he doesn't want to pay the gas fee. So client has to do that. So the server can only read data from the blockchain, which has no gas fee, and then show the data it has read from onto the website on the website front end. Now let's have a look at the smart contract we have created. So we have used factory design pattern for creating events, and the reason for that is that a particular manager or a particular account can create multiple instances of events. Like the same manager can organize Diwali event and then Christmas event. So for that purpose, we had to generate an event factory contract which can create multiple instances of event. So the flow would be that whenever user clicks on create event, we instruct Web3 and MetaMask to show user a transaction that invokes event factory, and event factory will deploy a new copy of the event onto the blockchain, and corresponding deployment cost has to be paid. After that, we tell event factory to give us list of all the deployed campaigns. So this is the event factory contract, and it contains all event variable, which has a list of latest 10 deployed events. And the functions in this contract are create event that, as I already said, deploys a new instance of the event and stores resulting address, and get events, which returns back the list of all deployed events. Now this is the event contract and the main contract of our project, and it contains all the functionalities and the data that has been used. So the first variable is manager's address, and the next is the description about the event. Then this is a request list which has the requests that are all the requests that are created by manager. Then there is contributors address list, uh, which records all the contributors into the particular event. Then there are contributors. So this list is the addresses of contributors and their total contributions. This is the mapping. So contributors address list have just the addresses of contributors, and contributors mapping has the contributors mapped to their total contributions. Then there is the minimum amount variable that has to be contributed to become a approver or a validator uh, in the event contract. Then there says the event end date, and this is the total amount collected uh, by this contract and since the creation of contract. Now the functions in this contract are first the constructor function, which sets the minimum contribution and the owner's address. Then contribute. So whenever someone wants to donate funds to the event and become an approver, he will call that this contribute function. Then there's create address, which can only be used by the manager to create a new spending request. And then there is approve request, which is the function for validating any transaction by any request made by the manager for any transaction. Then this is the finalize request. So after request has got enough approvals, manager can call this to get money sent to the vendor. And this is the refund all function. So after the event is ended, and if funds are not totally used, then they can be returned back to the original contributors. So in this way, by creating this event contract, we can ensure that there is total transparency from the manager's end. Now let's talk about compilation and deployment. So we created the event smart contract, and the Solidity compiler creates the contract bytecode and ABI. So the contract bytecode is deployed to the Ringby network using Infura, which creates a node to connect to the Ringby network. And the ABI is used by the React front-end application that we have created to fetch the data. React front-end application uses the ABI, which is the output of Solidity compiler. Now this shows the role of Infura. So Infura creates a synchronized node in the Ringby network, and using Infura API, we can connect to the MetaMask, which is in turn connected to the Web3 instance of our, which is created in our project. And MetaMask takes in the account mnemonic, which will be showed by Hardik in the demo. Then this is our Ringby blockchain. So user can request to create an event, and Event Factory would keep creating new instances of the event and deploying into the Ringby blockchain and storing the list of all the events that are created by Event Factory. And then our site can ask for the all the deployed events from the Event Factory, and it will return back this list. Thank you.
So hello everyone, I am Hardik and I will be giving a demo of the project that we have done under this course project. So this is our code and I will just launch our web application. It will start in a minute. And yeah, so it is starting. So yes, so as you can see, as soon as the website loaded, so first thing what happened was that MetaMask is launched and it is asking to enter a password. So I will enter the password, and once I enter the password, you will see that it is asking to connect our accounts, that the website is requesting to connect our account with this MetaMask. So here I have 5 accounts, so I will be adding all 5 of them. So as you can see, the first account has around 28.8 ethers. Second account has 2.49 ethers. Third and fourth has 2 ethers, and fifth has 0 ethers. So, and for this web application, we will be doing this testing on Ring B test network. So it is not it is different from the main Ethernet main Ether network. So I will connect, and as you can see, as soon as I clicked on connect, our website is loaded, and these are all events, and this is the homepage of our website, and it shows the recent 10 most events, these recent top 10 events that have been published. So I will be talking about this page in great details, but first let's discuss a scenario. So yes, so the scenario is that here you can see that the account with which I am logged in right now. So if I change my account in MetaMask to account 2, which starts from 05D, you can see. So, and now if I refresh the website, then it will show me that 05D. So my accounts with the account which I have logged in with this in this website has changed. So I will go back to now the first account and again refresh the website. So yes, so the scenario is so similarly in this fashion, I have created five accounts for this demo purpose. So and all of these are on Rigby test network. So everything that we are doing will be on Rigby test network. So this is the yes. So there are few scenarios that I will be explaining, through which it will be clear that how our application works. So the first scenario is so since we have 5 accounts, so we will have 5 A1, A2, A3, A4, A5 accounts each, and I have entered first 6 characters of each account address here. So scenario for A1. So A1 is suppose wants to organize an Diwali event in society and wants to collect fund for the society. Okay. So A1 will be, so what he will do, A1 will visit to our website and will create an event. So A1 will now be the manager of this event. So this address will be like 160-bit address will be manager of this event. And then after creating an event, he will get an address. He will publicize the address. After the publication, he will spread the address to whomever he wants to contribute in his event. So suppose he spread that event address to A2, A3, A4, so they can search for that event using the address. So I will be showing this thing. So now you can see that I am as an account one is selected, and I will go to this page and I will go to create event. So description would be, so suppose Diwali event, and the minimum amount, so the minimum amount that a person has to contribute each time if he wants to contribute. So suppose I will do it around 2000, 12,000. Okay, 12,000. And this date, as you can see that all the past dates are white, disabled. So you have to provide a future date. So this future date is nothing but the expiry date of the event. Suppose that Diwali is on 18, so I may choose to enter 18, that all the funds will be like this event is valid till 18, and after that it won't accept any more funds, and refund is possible. So I will do select this 18 and around for just let's select it, and I will now create event. So once I create an event, this will happen, and now you can see that this thing has popped up. And so this is the miner address who will receive this transaction fees. And so once I click on the confirm, so since I am changing the global state of the Ethereum Ring B test network, it will consume some amount of ether. So just I will click on confirm, and it will now have like the miner will now process the transaction, and it will create a contract. So the factory contract will be invoked, function will be invoked, and it will create an contract. And once it creates a contract, it will tell us the address. So here is the address of that contract that we just published now. Okay, so I can copy this address and uh, so this is the address where this contract, the contract that this event Diwali event has been published. This is the address of that contract. Now I can simply visit to my home page, and let's see if I can see. So yes, so you can see that this is Diwali event, and so this is managed by Zero AC. So you can see that this is my address, Zero AC. So I am the manager of this event, Diwali event address. So this is the event address where it is published at. So it has 0 requests. So these requests are the request to spend fund. 0 contributors, so no one has contributed to this contract. 0 collected, so this is the total amount since this contract has collected since it was created. So we have created this it just now, so it has no money. This is the balance, this is the remaining balance. I mean, the amount of money that contract has collected versus the amount of money it has currently now could be different, because if they have spent it some money, like they collected 100 and they spent 50, so the remaining balance will be 50. So this is the minimum amount of way people have to contribute, and this is the expiry date of the contract. Okay, and this is the description, Diwali event. So yes, so this thing is clear. And you since I copied it, suppose that this event vanishes from here, and now I want to get back to this event. I have some address, and why I want to get back to this to that address. So I will go to this my profile. Like, I will click on profile icon, then search event, and then I will add the address. So the address is this, and once I click on search, you can see that this Diwali event has. So this address and this address is matching. So the if the address that I am putting, if there is some valid contract, that is valid event contract at that address, then that contract will be shared here. So the when I say publicize the address, so the creator of contract will publicize that address. Okay. So now I will move on to the second event. So contributing to an event. So suppose this Diwali event has been created by A1, and he sent us he sent this address to A2, A3, A4. Okay, and maybe he sent it over WhatsApp or some other email or something else. So after receiving this, A2, A3, A4 may now choose to contribute. So what I will do, I will select I will go to this. Now I will switch to my account 2. So here you can see this is account 2, and now I will refresh. You can see that this is Diwali event. So I may choose to contribute to this event. Now you can see that I am at account 2, 5T61, and here we can see this is 5T61 account 2. Okay, so now I will go to Diwali event. Now I will click on contribute. So what I will do, all peers have received address of the event from A1. They can either view it on their home screen, like I have done this way, or I can just simply go to the search event page and enter the address and click on the search icon, and I will get this address. So I will do now what I will do, I will click on contribute. So the minimum amount of ether that I can contribute is this 12 much. So I will click on uh, let's do this. 1 ether 2 3. So this much money. Okay. So I will pay around this amount is equal to 1 way. So I will just let's say I will pay 1 way, and this is the data. So it is showing me that I am paying 1 ether. So total will be 1 point this much amount of ether, and I will confirm. So it will take some amount of time because the miner will process and the whole block. So this he will find the solve the puzzle and find the nuns that like that solving the puzzle business is going on. And once he does that, this transaction will be processed and he will receive the transaction money. And this I would have paid 1 ether to this contract. And now you can see, so if I go back to, you can see that this amount has this event has collected 10 to the power 18. So this is my, so this correspond to 1 ether. Okay, so now, and it is showing that there is one contributor, and there is this much balance. So balance is right now equal to collected because we haven't spent anything. Okay, similarly I will do this thing for account 2 and account 3 and account 4. So I will go to account 3, and first let me copy this address. I will copy this thing, and I will go to account 3, then refresh this website. As you can see, it's 0x869. So 0x869 is this thing. So that's that. I will go to search event, then I will add that address, and here I can see I've got. Now again, from this A3 will also contribute some amount. Suppose he only paid 12,000. Let's just say, for sake of time, uh, just I will confirm this thing. So this my, now again this transaction will be processed. So A2 and A3 will also A3 is now doing this thing. Similarly, A4 will also do for our scenario. See, right now A3 is doing, A4 will also do. So yes, so let's see if it is complete. Yes, so okay, so okay, and we will see. It is search event. If I enter this thing, pay, and now you can see that there are 2 contributors, and see that this value has increased from to 1 ether to 1 point some like those 12,000 waves have also been added. Similarly for account 3 I will do the same thing. I will change my account. I will go to account 4. Now I have to refresh the website. 0x6C94, and you can here also see 06C94. So this, they will go to search event. He will also go to search event. He will add and this, and here he will also contribute. Suppose I did this which he paid. Then the this MetaMask screen appear. He confirmed. On clicking confirm, the transaction will be signed. This signed transaction will go to the miners. Miners will solve and create a block. This block will be published on the, if once this all the transactions within the block are verified, then this will be published and the global state of the blockchain will be changed. So as you can see, there are 3 contributors here, and you can see that 1 2 is more added. So this amount has changed again, and so the scenario 2 is also, so the contributing to the event is also finished. So we will now see the third scenario. So creating a request. So as you can see that uh, since this account was, this event, Diwali event, was created by account 1, and right now I am at account 4. Okay, so I am not seeing any way to create a request. So only a manager can create a request to spend funds. Okay. So what we will do, so I will now change, since I am at account 4 right now, I am at account 4. So I cannot create a request to spend fund. So I can only see request. Since I have contributed, I can see request. Okay. So let's suppose I will change my account to account 1. And yes, and now I will refresh this website. I will go to search event and I will enter this address, and yeah. So now here you can see, since I have changed to this 0AC1 and the account 1 is 0AC1, so I have changed to this first account, switch to first account. And here we can see, since I am the manager, managed by this, so I am the manager, I can see here a special function called create request. So all the events that are created by me, there I can create requests for them. So since all these events are created by this, so this Ritwik's party is not created by me, so I cannot create a request here. And since I am also not a contributor of this event, so I cannot see request. So only those events in which I have contributed, I can see request corresponding to them. So only a contributor can see request, others cannot. So I will go back to this uh, here. So let's suppose I create a request of spending fund. So what I will do, so description. So for Diwali, suppose I want to spend money on purchasing some sweets. So purchasing sweets, okay, and receiver address. So this receiver address is nothing, but this is another account in this thing. Okay, so what I will do is I will show here. So this my account 5 has currently 0 ethers. Okay, so what I will do, I will go this. I will switch to this account 5. I will copy this address. So account 5 address is copied, and right now it has 0 ether. Click. So I will switch to account 1 again, and now I will go to this search event page. I will enter the address. So what I will just do this thing from here. So I will refresh the website, and now you can see that 0xAC192. So this is the account 1. So this manager, I will go to this and I will create a request. In this request, I will enter uh, purchasing sweets. Suppose we want to purchase sweets. Now I will enter the address. So this is the address of fifth account. We can see 0xEB76, 0xEB76, and amount I will do is let's say uh, it might give an error here. So it will give an error because it's a very big number. So let's see. So here I have created a request, and it is showing that this many ethers. So I will create a request. So actually this money is not being transferred right now. It is only a request to spend this amount of money. So this amount of money should be transferred to that account which I have sent. Okay. So yes, as you can see that on the Diwali event, we have got this one request. Okay. So I will copy this event address. It will be faster that way. Okay, one request. So now I will go to this. I will enter this search, and now, so if I click on show request, so a purchasing sweets, and this amount has to be transferred to this address, and number of approvers, since the number of approvers is equal to number of contributors. So as we saw that there are 3 contributors. Okay, so the number of people that can contribute to, that can approve this request will be 3. So I cannot approve this request since I have not contributed. Account 1 didn't contribute to this event. Only account 2, 3, 4 has contributed. Okay, so if I try to approve this request, so let's see. So this the transaction error exception will be thrown. Okay, so this transaction won't be. So MetaMask is warning us that even if we confirm this sign on this transaction may fail because there is something error occurred in the code while execution. So I will just reject this request and MetaMask transaction signature user denied the transaction. You can see if we cancel the transaction, the signature MetaMask won't sign on it. So okay, so what I will do, I will go back and now I will so approving a request. Now we will see how a request is approved. Okay, so I will switch to search now since I'm at account 1 and account 1 is not the one who contributed. Account 2, 3 and 4 are the one who contributed, so I will switch to account 2. So here I will go to account 2 and now I will refresh the website, and here you can see that search event. I will press this, so show contribute. So I have already contributed here, so I will go to show request, and now I can see that here is a request for purchasing suite, and this is the address who will receive this money. So I will click on approve, and once I click on approve, then the MetaMask, you can see that now I don't get any error because I am a valid contributor. So I will click on confirm. So this validity of contributor, like is the given address valid contributor or not, is done at during the time at which we uh, in our smart contract we have. So you can see the contribution have increased to 1. So but we can if I switch back to account 1 who is the manager, so if I switch to account 1 and refresh the website, I'll go to this search event. If I enter this and this, if I click on show request, this request still can't be finalized because the number of approvers is less than the majority. Okay, so the number of approvers must be in majority. So at least two it should have approved the request so that it could be finalized. Okay, so I will again go to this. I will switch to account 3 now. Account 3, who is also the contributor, and refresh the website. 08691, you can see 08691. Okay, so I will go to search event. Now I will add the address this. Now I will go to show request and I will click on approve. Okay, so again this request will be, so you can see that there is no exception here, so I am a valid contributor. So it will take some amount of time, and if I again, I will also show that if I again try to do approve this request, then also I will get an error. Let's just wait. And yeah, so we can see that two requests have been approved, and the status is pending, so it has not been finalized yet. So I will click on again approve, and you can see that transaction error exception thrown. Since I am retrying, I have already approved this request once. MetaMask is warning that if we try to execute the code, this transaction will fail. So I will reject this request, and there is this error again. So now since I will switch to account 1 and okay, and refresh the website, and now we will move to another scenario. So scenario for A1, now we will try to finalize this request. Okay, so as soon as the majority vote approvals have been finalized, a manager can finalize the request, and after finalizing the request, the amount will be received by the receiver. So what will happen, let's see. We will go to this. I will go to search event. I will enter the address here. So 0xac19. So this is the address of the manager here, you can see. So now I will go to show request, and I can see that here is finalize is now available because the majority has voted approved to this request. So I will click on finalize now, and I click on this thing, and now I will confirm on this transaction, and let's just wait. And you can see that this transaction is done, and now no one can neither approve or finalize because this transaction has been done, and the fifth account will receive the money. Let's go to this account 5, and you can see that this amount has changed to, you can see here, not here, but you can see here that this amount has changed to 0.0001 because we sent that much ether. And this so we can see that the actual, so this was the address of the person who was selling the sweets, so he received this many ether, and now we can, the account the manager can get the sweets in return. Okay, so in this way the people who contributed can see and see that where there is money is actually being transferred, because they can see the address of the person who will receive this money. So okay, and now going back to the slide. So we are done with the demo and workflow and challenges. So the workflow is, we found out a problem. So the first thing that we did was we found out a problem that to solve using the blockchain. Then we studied how Ethereum and smart contracts work. So the problem that we found was not we were not able to solve this problem. Like we needed a voting mechanism. So for this kind of problem cannot be solved easily by a normal standard server client of architecture, because we have to trust on the server. But in blockchain there is no trusted party exists. So that's why uh, so we studied about Ethereum and smart contract, and where majority consensus rules are used. So then we created a smart contract solution and deployed it on the blockchain, and then we did our testing and debugging of the smart contract, and then finally we did the integration of the blockchain data with our front-end web application. So once we were done with our smart contract and we tested that it is working correctly, then we created a front end which I showed you just now. So this is it. So yeah, so that, and the challenges that we faced were the biggest challenge that we faced were outdated documentation. So Ethereum and blockchain are relatively newer technologies. Ethereum was launched in 2015. So the frameworks like Web3 API endpoints and frameworks such as Truffle are changing very rapidly. So most of the problems that we searched on Google, like the programmatic bugs, like how to pay transfer money in smart contract and other things, were outdated solutions. So they didn't work properly because the solution was written suppose 2 years back, and a new framework, like they changed the library 1 year back. So the code so that solution is outdated. So this kind of problem we faced majorly in deploy.js and compile.js. So compiling using Solidity compiler and deploying using a deploy script, these both scripts were created by us. It took extensive amount of time to create this these scripts. So that's the, and yeah, thank you.